So the outdoor unit is blowing cold air. It did just down cycle, so it's not actually blowing very hard on me anymore, because I just confirmed that everything is working, but it's certainly blowing 67, and the outdoor is a little closer to like 75. So a small temperature decrease. And what we have here is the pressure of the system in heating mode is going to be over 300 psi, and I'm going to go ahead and switch that over into cooling mode. But this is pretty much exactly what you would expect to see there. So I'm going to go ahead and just flip it over to heating mode and record that. Alright, so I currently have it set to 30 degrees Celsius, which is really hot, and it's currently 23 Celsius, which is, I don't know, actually. When I try to switch this over to Fahrenheit, let's see here. There we go. So it's currently set to heat mode. I just switched it over to Fahrenheit at 86. So let's go ahead and just switch this over to cooling. And let's drop the temperature down to 65.4. So what we're going to see here is the fan's going to pretty much stop pretty soon. And if I can get that pressure gauge in there. I'm not actually sure if anything's going to happen, so this part right here might just get skipped through. But looks like the fan is now entirely stopped. So it's heard a little bit of noise there. Let's take a look at these pressure gauges. It is currently hooked up to the bottle of refrigerant there, and the purpose of this video is just to show what proper pressures look like after everything is hooked up. Then I'll explain everything that is hooked up. There's about a 3-minute delay in everything that I have here, so I'm going to just use that time to fill in all those details. Let's see here. The R410A is actually put on a scale, and you weigh it in by the amount. So you're going to sit here and watch your pressure gauge, and then you're going to look at your scale down there. And this system calls for 1.85 kilograms, and that is what the scale is reading right now. And you add that in. You do want to add it in upside down so it pulls liquid out of the tank. Oh, I just heard a valve go in, so we're going to see what those pressure gauges do, because I think the fan's going to kick on soon. Guess not. The blue valve is hooked up to the vacuum pump. For the low pressure side, it's currently closed, and I'll explain that a little bit. And then the high pressure side is hooked up to the refrigerant there, and it is currently open, but the valve to the tank is closed. So the current pressure right now is just the static pressure that we're reading. It's about 75 degrees ambient temperature. I guess a little chillier, about 70 degrees now. The sun's gone down. So any minute the system's going to start up. This type of delay is entirely normal, which is also why I wanted to film it, just because I wanted to know for myself, because I'm not a very patient person. But it looks like there it is. I wanted to keep the temperature gauge in there so you can actually see the pressure is slightly falling on the system. The air that's blowing out starts a little bit warm. So we're pulling about 10 not much warmer. This also doesn't start up at 100% power, it actually ramps up. So you gotta give this thing about 10 minutes. Alrighty. So the process for this was I cut off the fittings that they gave me, which were a total and complete failure. I had pushed that in as much as I really could in order to get that fit in there, but it just didn't push in. I watched the YouTube video. I followed all of the instructions that a reasonable person should be expected to follow. I've also done this, more than once. So it's just too difficult of a product to use, and I would say it's failure. So with that said, went ahead and had to go ahead and redo everything because I had done the line sets exactly perfectly. I didn't necessarily have the space to redo it, so I had to just cut them off with a saw, which had a negative impact of actually possibly introducing some copper fittings. So inside of the pipe I actually shoved some saran wrap deep into the pipe with a chopstick, and then did my cutting. And then when that piece of saran wrap is pulled out, that should clear all the shavings. Since these pipes are open to the air in Florida and it's really humid, I actually went ahead and just hooked my air compressor up to this with a 1/4 to 1/4 fitting and just blew it through. And at first I thought that the system, that there was a clog in the system because I couldn't find the tissue, or not a tissue, actually it looked like a tissue, but it was just a piece of saran wrap, and it had actually fired across the room. So it had definitely cleared the line and proved that there was nothing inside of the line set, which is what we were really doing. I was also trying to expel any copper shavings that would have been introduced by the use of something other than a standard copper pipe cutter that kind of goes in a circle. And just to interrupt my spiel there, but this is what our pressure is looking at, around 150 at a current ambient temperature of 72, with the system set to as low as possible. So typically you would not actually use an air compressor to test the fittings. I did. I have one for my truck, so it was able to test it up to 150 psi and get it to hold that. So that was my first test of the lines, just to prove that there was no loss in there. I could have done that same test with refrigerant, but after quite a few losses of refrigerant, I decided I owe the EPA using some air first. Now the reason why dry nitrogen is typically used is because it's dry nitrogen and it does not have any water inside of it, so running it with the air compressor did unfortunately add some water into the system, which of course assumes that the lines were dry, but since mine were open to the air and everything was essentially foggy today, there was definitely a lot of condensation in there anyway, so the pump had to run pretty much all day. And the vacuum pumps are definitely not designed to run all day, so it had to be kind of on and off. Otherwise, the system will engage the thermal shutdown, and in which that case, it'll probably be off for about 15 minutes, and then it should turn back on again automatically. Anyway, yeah, the temperature of the indoor looks to have dropped down to 75 or 75 inside, with the set temperature at 62. Not sure what it was before. but just recording that kind of a temperature change, figured was worth it. So just to cover what I did in its entirety after I had run the air through the lines to do an initial test, which is typically done with dry nitrogen. The next step is to go ahead and I hooked up the tank as you see here, and I ran some refrigerant through just the lines, which means that the hex keys on the side up here were actually both closed. So I simply filled the part through into the indoor unit and then through with refrigerant, and then sealed that up to the atmospheric pressure that it was, which was about 200 psi. And then I just closed this valve off and closed this valve off and then checked it, waited and checked it again, and just saw no loss. And I also pulled out a refrigerant detection device, and I was looking for any refrigerant leaks, and I also used bubble leak detector right here in order to look for any leaks. Found no leaks in the system. So I then went on and moved on to the next stage, which was, unfortunately, after researching the answer to this to confirm it, was to actually open up these two valves and then pull a deep vacuum on the outdoor unit, which includes the compressor. And the answer is, am I going to pull all the oil out of the compressor? No, I'm not. It's not designed to do that. You simply pull a vacuum on it and you're fine. That is the way it's designed to work. So once I had done that, which also pulled all the refrigerant out of the line sets, I then went ahead and hooked the system up again and verified that it holds the pressure. It did. So then went ahead and weighed it in, and that was actually pretty easy. I actually just opened up the valve right here, and the refrigerant just flowed in through the vacuum that was left by the line and into the system, and I didn't actually even have to turn the thing on. It was thirsty enough to pull in a full 1.85 kilograms, and the 1.85 kilograms is actually from, well, I guess if the cord wasn't in the way, it's on that sticker right there. 65.2 ounces. So that was pretty much all the tools that you need for this. In my initial setup for this, there was a problem with the valve stem, and thinking that the valve stem was not faulty, I had actually over torqued it and broke it. So this little 5/8 and 1/4 adapter is now a permanent fixture to the system. But however, it does not leak, so that'll work. Otherwise, this is kind of what you get when you get a scratch and dent free unit. But hey, testing is over, because this thing has never actually worked. It's always taken apart. So now it gets to officially work, which is fantastic. Anyway, the next part of the test was to actually just hook the system up and then do an actual pressure test of the system. So you send it in the cooling mode, and you're going to see the pressure from the initial 200, and it actually fell into like the 150 range. And it's done that. This is the second time I'm doing it. And in the heating range, you should see it go up to about 300. I'm actually just going to go ahead and do that right now while I have this on film. Just going to take the app. Heat. See, as soon as I flipped it over to heating mode, the pressure automatically shot up. Not sure if I caught that on camera or not, but it shot up from the 150 to about 200 there. The fan is still running, but I believe it's kind of just doing a cool down, reversing cycle process there. So that's going to take essentially just a minute to let it do its thing. This little shipping scale that I got here was just a far cheaper alternative to the probably more durable HVAC scales that I was seeing, but didn't necessarily, those which didn't necessarily have the other features I was looking for. Like, okay, cool, I want a scale that I tell it I want 1.85 kilograms, and then it starts beeping, beep, beep, beep when I get close, and then it sends like an alarm when I go over. And they didn't seem to have that. So, barring an intelligent scale, I just decided that I would rather have something that is much higher weight, so I can stand on that. I think it does 400 pounds. So right now the system is entirely off. System pressure is 200, and it's on heating mode. And you might be thinking, oh, it's broken. No, it's just kind of thinking and doing its stuff. It needs a minute. This is normal. But this delay is very, very abnormal looking. Let's see here. I don't really have much else to add. Definitely add Nylog to everything, including these connections when you're doing these, just so that when you're watching this and you see like the pressure leaking out, you can be confident that it's not leaking out at one of your fittings, and that it is actually just something with the system. Because that's a lot of what this is just being confident and understanding how it works. Because if you can understand how it works, you can fix it. So let's see here. It looks like in my haste to shorten these lines, this guy just didn't quite fit anymore, so I'm just going to go ahead and cut it and deal with it another way, so because I have to wedge it. And then cap these off. One of the things I wanted to point to, is if there are any leaks in these threads here, which you will get if they are not fully seated in the open position, you'll get some bubbles in this nylog, and they will form a cluster of grapes for this type of leak, and I'm definitely not getting that. You'll also see some movement with the bubble leak detector. But so you spray the blue stuff right here, big blue, into all of those fittings. Oh, I want to check this pressure. So you can see I caught it there on the pressure rising up. It's in heating mode. So you can see we're pushing over 300. I don't think the system's really going to push much higher than that with its ambient temperature. If the ambient temperature outside was closer to like 85 instead of 72, then I would see that needle gauge push itself all the way over into the like 400, 500, 600 range, depending on environmental conditions. But what you are expecting to see is for the system to go ahead and push itself essentially to a red line, like push itself up and then pull it. Oops, let me get this in frame. You're going to see this needle kind of push itself up and then pull itself back, and then push itself up and pull itself back. And you'll do that at 100% power mode. This system is not running at 100% power mode right now. It just started up, so if I were to have a accurate way to show you the power in this video, you would probably see that it's probably only running about 25% power. But within about 10 minutes, it'll hit full power. It doesn't really sound much different, and it does not really feel much different in terms of like what you kind of feel at the outside unit, but it's there. It is there. So that is it. And this is the highest pressure test that we can really get with the system, which is going to be essentially just a 300 psi heating test. So that's essentially the purpose of this. So right now at 300 psi, if I had a leak in any of my fittings, then when I hit this with the micro leak detector, like I hope I did in frame there, then you're going to see some bubbles forming. Now when I spray this stuff, it actually forms bubbles when I spray it, so don't confuse the bubbles that it sprays with the bubbles of a leak. The bubbles of a leak are going to continue to grow and form a cluster, kind of like if you were to blow bubbles. Whereas on this, it's just kind of basically just get sticky and drippy, and not really change from what it looks like right now. It's definitely noticeable. Now the system just went ahead and ramped itself down. The fan speed slowed down a lot, and our pressure here is just slightly over 300. That could be, let's see, I'm reading an indoor temperature of 73 Fahrenheit. So the system should be really pushing here. If you ever think, oh, the system's not doing what it's supposed to do, or it's not responding, just give it a minute. There's no reason to overanalyze it or turn it on or off or do anything like that. Like, it does its own thing, and it's pretty smart. So essentially trust it. But yeah, essentially I'm reading a coil temperature here of 66. Yeah. And with an outdoor temperature of actually about 69, so really not much of a difference there. We're gonna go inside and check for leaks. So the inside systems do not have any leaks. Did cover them in micro leak detector, which is why there is some paper towels below them to catch all the dripping. Now, this system did previously had fittings, and it literally dripped refrigerant right from those fittings, so it's pretty obvious to be exactly what it was. And it was not necessarily difficult to see what the problem was. So don't overthink it. If you're dripping something from here and it's oily, it's 100% refrigerant. If you're dripping something from here and it's not oily, meaning it doesn't look like a French fry bag, then it's just condensation, and you should insulate your pipes with a little bit more insulation, which is something they didn't give you in the box. And this is very warm and dry, or wet air. It's blowing on me right here. Whew. And yeah, I would definitely say it's working. Getting temperatures there that are pretty toasty. So yeah, definitely working and warming. So, and definitely heating up the entire room, because it was previously just on AC mode. While that starts up, I might as well include a video of how beautiful all of this is, because I figured someone might want to duplicate this. So what I did is I tapped into the drain line right here, and instead of using their corrugated tubing, I went ahead and replaced that with clear tubing, which is the same diameter and fitting size as the 3/8 reverse osmosis fittings, so you can kind of see what they look like right there. And then I used a mini split condensate pump. So this is the little float switch right there, and this tube right here has to come all the way up and be, let me zoom out here, has to come all the way up and actually be higher than the condensate drain pan right here. So it comes all the way up and it goes on to the side over there. And then that tube runs behind it, and behind that cool blue LED light underneath these tissues, which I suppose I can remove now. And I guess we don't need this blue plastic either. Gotta keep your line set safe. and it's still blocked. Oh. It's that right there. It's there, you can see it. It's got a label. It's a little condensate pump, and then it kind of goes through. And it just has a couple different options. There's a couple of valves and different reverse osmosis fittings to where I can valve it off and send it inside to use it for watering plants. Or it actually goes outside to water plants. So that's how all of that works right there. And there's a handful of different electronics. Let's see what we got here. This 9-volt battery and a buzzer that we have right here. This is actually for the alarm. So in the event that this system hits some type of air condition, it'll trigger an alarm, and I have it hooked up to this just 9-volt battery and buzzer. So anytime the alarm trigger on this is functioned, and then of course this guy is, you can turn it on and off with this switch, but anytime the alarm functionality is triggered, which is typically the water overflow, it'll make this buzzer beep, so you get an audible alarm and not just the system flashing an error code. What else did I do? I tapped into the L1 and L2, the power connector, with just some 1/4-inch spades wrapped in shrink wrap. Specifically the marine shrink wrap that's sticky, so it goes all the way to the edge, so you can go ahead and touch it right there, and it's electrically connected. And this is just a standard USB charger. You want one of the world chargers that says it works with anything between 100 and 240 volts, and then you're just fine. And this USB right here allows me to hook in a infrared temperature sensor or a phone charger or just whatever else you happen to have. Moving over to this over here, I actually have 2 transformers. That's these 2 bolt bricks right here, 40 millivolt transformers, and I have those just wired in with these Wagos into the electrical box, and those are stealing power from the 240 volt and giving me 40 volts AC, and those drive the LED lights, which is what you see there, and they're kind of giving you that glow for the system. So those are all the add-ins that I did for that. There is also Wi-Fi built into this wired controller right here, and let's see here. That's about it, really. Other than that, it's a basic system and it works great. I have it right now on dehumidify mode, so we're going to go ahead and just check that temperature and see what our coil is reading. So our current system on the front face, 79 degrees, so we're still kind of warm in here. And there we go, okay. So quite a big temperature difference there, pretty chilly. It's running in defrost mode right here. Now I would be expecting this defrost mode to get myself all the way down to just below freezing. But I'm not sure what stage the system is in right now, so I can't necessarily say it's not working. I just need to basically just give it a day, come back, see if it pulled a lot of water out, and if it did, it works. Same with heating and cooling. You more or less just see if it works. Does it make you warm? It's working. If it doesn't, then there's something going on with it. If it's working but just not giving you the performance that you need, add more refrigerant to the system. But that's it. Everything is overall working pretty good. I figured I would just kind of show what it looks like here. Ignore the messiness of this, as I didn't quite clean it up from the other connections. And I also wanted to disprove the myth that you can't cut these wires. You definitely can. There's nothing special about them. They just run power and communications. Now, if those were fiber optic wires, then that would be a different story. I would definitely not recommend the Wagos for that. But I want to say I'm pretty happy with my results here.